To make a variable resistor, I'm going to need something that resists the flow of current. And this Nichrome 80 wire here will do just fine. It's 26 gauge, and I've got 100 feet of this stuff, and I just opened this up. So this wire is special because, unlike copper wire, it has a non-negligible resistance. So it's a measurable resistance, and if I take about a foot of this, which is the length of one of these tiles on the ground, so you take roughly a foot there, and I measure that foot of wire, you're going to see that the resistance is going to be roughly 3 ohms, 4 ohms, alright, 3.5 ohms, something like that. Alright, so my Wirewound variable resistor is going to be built in a similar fashion to this Wirewound fixed resistor. And there are a couple of good points that I like to point out about these things before we get started. Alright, first one is, if you notice carefully, that these power handling capability is quite high, which is useful if you're doing something with fairly large currents and you're going to be dissipating energy. It's also pretty low ohms resistors, and it's another property that you have to take into account. Inside these things, there are just coils of wire that dissipate energy as heat. And that heat is gonna end up melting your wire if you don't draw it away from the wire. And in this case, there is this sort of potting stuff, or this casing on it, that draws the heat away. And you can take a look on the package here. This is the Radio Shack Wirewound resistors. They have some sort of fireproof something or other in there, and they've got inorganic potting compound that provides high thermal conductivity. So for me, I have to somehow mimic this property, alright, or at the very least have a coil form that isn't flammable, that will heat up and burn as I use it. Alright, so let's take a look at what I have here. And this material is all around me. You can see on the ground right there, tile is relatively non-conductive, and it's also fireproof. You can't really burn tile, right? And I've got a spare piece here that was going to be dumped in the trash, but I was like, hey, save it for later, and here, finally, later is going to be of use. So I don't want to jump in items. So what you do is quite simply take your piece of tile and wrap the wire around. There's really not much to it, right? This Nichrome wire, just make sure they don't overlap, so they don't short any turns out. Wind it like you would an inductor. You could use Kapton tape to hold down the wire as you wind it so it doesn't pop back out on you. And really, it's quite straightforward. So I've got 20 turns or so on this piece of tile, and I'll be testing your resistances next. Here's the completed windings, and the only reason why it's wound is obviously because I don't want 10 feet of wire in front of me while I'm doing this, and the ends of these are just attached to terminals right there, and those terminals are now attached to the multimeter here, and it's reading the resistance, about 28 ohms or so. And the way to make this variable, again this is just temporary, is to simply take a clip and short out the windings you don't want. And obviously, because you're shortening the coil, then your resistance is going to drop. Your electrons are going to love this path more than that path, so they're going to go there. And that makes for a variable Wirewound resistor. Right here is the semi-finished product. This is, again, temporary, so I'm going to be leaving it at this. I could clamp a piece of wire in between these two washers to attach it to the next item in line. And that'll be perfectly fine for what I'm doing right now. But I'm finally here starting to dig myself out of the hole, and if anyone's used Ubuntu, something like that, when you try to apt-get something and you're missing dependencies, well, this is kind of like the you finally found something at the very bottom of the rabbit hole. And now, it's time to move on.